Thinking.
I will look up a transcript. I can take notes in the transcript. I can't, when someone
All right, guys.
there's something for you to look at.
Jump back up here. We got 2 more days to talk about this before we take our test on Monday. Remember, you guys will have a late arrival on Tuesday, so you will not be in here. I'm thinking about actually throwing a video up for you. All right, which would be the day 1. Are y'all all hearing this? I'm thinking about throwing a video up for you because I'm looking through the year and we're already a good chunk of time behind and not losing a day.
6 days or more?
Yeah, something like that at this point. It's kind of hard to say because some other things have been moved, like ACT testing and stuff like that, so it's hard to say, but it's somewhere in about a week behind, so I really don't want to lose another day on that. So if I can steal that back by throwing a 50-minute video, I will see my other class in the afternoon, so rather than just do nothing the day after the test, I might do that. So I might have something for you, but I will update you before then. So I just want to jump back to some more of this stuff. Again, 2006, I know that for a lot of you, you were pretty young at that point, 3 or 4. This is yesterday to me. 2006 was just a day or 2 ago. So right here, but my point is it's getting more recent. I haven't really, in the 9 or 10 years or whatever that I've taught Apcalc, I haven't seen a whole lot of change in the kind of the way they ask questions. It feels very comfortable here. This was just right before that. So, and you can see another question where they give you a slope field, they ask you to sketch it based on that differential equation, and then they ask you to solve the differential equation specifically at that point. And so we're going to do 1 or 2 of these, and then we're going to jump into some sketching of the actual solutions, which you probably haven't done a ton of, and you've probably done a little bit if you've done all your homework, but we know how that goes. So right here, consider that differential equation. Help me out at these 8 points. And again, notice they didn't give you points along the y-axis. Why do you think that is? Because they're undefined there, and they try to avoid that for some reason. Now, if that changes, then put a vertical segment in there. But I have yet to see one in the last 15, 20 years where they've asked you to do that. So they're kind of avoiding that issue because some people put them in there, some people don't. But anyway, right here, if I'm sketching these, I'm going to start at -2, 0. At -2, 0, what do you get for your slope field? I mean, for your slope at that point? -0.5. So I'm sketching this so that it looks like it goes towards, or makes a line that has down 1/2. So I'm sketching that slope out like that. And then at -1, 0, looks like a -1. At -1, 1, looks like a -2. So again, I'm sketching that so that it looks kind of like that line, except not the line. And then what about at -1, -1? 0. And then when you go to the other side, what about at 1, 0? 1. What about at 1, 1? 2. And again, I'm making that so it looks like it would be a line with the slope of 2, but not the line. And at 1, -1. 0 again, and at 2, 0, 1/2. So do the best you can on those. Be careful. It seems like every time somebody misses something on this test, and I go back and ask them, hey, what'd you do there? They go, oh crap. It's always a careless error. Some careless errors, guys, are really not, I know you say, oh, I was just careless, but it was careless in concept. Like you forgot a concept, but you really knew it, but you just got tricked up. This is literally points you lose by just not being careful. And it's easy to double check that. Please make sure you do a good job with that. Now notice they didn't ask you to sketch anything. What if I asked you to sketch, I don't know, I didn't ask you, let's just move on. So find the particular solution to the differential equation. So I have dy dx 1 + y over x. How are you going to solve that differential equation? So dx comes up, 1 + y comes down, or or y plus 1. Would everybody have that? So when you integrate, is that a rule on the left?
No.
No, but I have found, and hopefully you've noticed this, that whenever you have something where you just have a constant when you do your u substitution, like when I make u y plus 1, my du is dy. Whenever my du is dy, nothing's really changing, right? I didn't have to put any extra numbers in there to balance anything out. When that's the case, I can just treat this like my u and not worry about anything else there. I really didn't need to do a big u substitution when it's just a constant being added on in that case, because it doesn't really affect the du and the dy. And at this point, you're going to exponentiate both sides, swing the c, and then what happens there also on the right? The e and the ln cancel also because there's no coefficient. So I end up getting 1 plus y. That c is just going to be plus or minus, but the c eats it. And then what happens to that absolute value of x? It just drops down. Doesn't stay up there floating, right? Because you learned that e to the ln of a is just regular a. So that e to the ln of absolute value of x is just absolute value of x. So the last thing we got to do here is subtract a 1. But this absolute value is still sitting there. And at this thing, I got to find the initial condition. If the initial condition is negative 1, 1, what happens when I plug the point negative 1, 1 into this? I get, when y is 1, I get c times the absolute value of negative 1, which is still c. I get c is 2. So here is my graph at the point negative 1, 1. Y'all seeing that? That's a 9-point problem, guys. 9. Like, it's almost criminal. It's like stealing from a helpless child their lunch money or something. I don't know. It's just so, once you understand them, it's just one of the really great gifts of this test is this, and what you'll see later with area and volume, because you really don't have to think overly analytically. It's just a process that you're doing. And on the free response questions, guys, you'll start seeing them more and more. They're normally not easy questions. Like, you really have to have a good game plan. You really have to be able to think and really understand the calculus to be able to do them, which I think you will. But yeah, to make an error.
I'm just wondering, like, when you plug in like the negative 1 into the absolute value of x, wouldn't it just be 1?
Uh huh.
So then like 1 minus 1 when that's 0.
No, it's c times that minus 1.
Okay.
So I'm just going to add the 1 over, right? This is c times 1, which is c. Yeah, it's not parentheses around that. It's order of operations to do that first. So I just add the 1 over. 2006 AB, I'm going to leave you that for homework. Okay, it's got a little trig in there, which means you're going to have to know your unit circle values. You got to know your derivatives with trig. If we have time, maybe we'll come back to it. But I wanted to do some other things here. Jump to the 2001. And I'm going to skip that 1985 below this because it's a BC and it has a natural log in it and it requires you to know that, and we don't need to know it.
So we just skip that one.
Correct. Correct. So in 2001,
This was a big year.
this was a what?
This was a way bigger year.
What is it? Yeah, it was a big year. I remember that was yesterday. It's hard to believe that's like almost 20 years ago.
Like no one was born that year, like
Oh, yeah. Yeah, I was. But yeah, no students. Yeah, I really do. I remember walking through the downstairs.
There's gotta be some. There's gotta be one.
2000.
actually the
I don't know.
2001.
To turn 20 here?
There's gotta be something else got new.
I don't know.
Yeah.
I don't know if we're gonna have
We have
Someone's
some,
bound to have been like.
we have 2000.
Well, sometimes like we have like a special needs population, they can be kept in the program till like 22. So there might be somebody, but
2002.
they were pretty young.
Even 18 years old.
Marina is 19.
We do?
Marina will be 19.
Yeah, he was a transfer from Kenya, yeah.
Ah,
So he was probably born in 2001.
he's 18.
No,
No.
I'm saying somebody in our grade, there's bound to be someone who was held back a year.
Who knows?
Yeah, but they're not that held back. Like Marina was, she came.
All right, guys. So refocus a little bit. I do remember walking down through the lunchroom, and they had a TV up or whatever, and I was like, "What the heck?" And then the whole school just kind of shut down that day, and everybody was just like staring at TVs before they started censoring stuff. Like I mean, some of it was really before they started going. We don't need to be showing all of this horribleness. But because it was pretty, this first hour or two was pretty awful. Okay. It was all pretty awful, but especially. All right, guys, so right here it says you got a differentiable function, you have a point on the graph of y equals f of x, and the slope at each of these points is given by that differential equation. Number one, find that and evaluate it at the point that. So what is that? That's the second derivative. So if the first derivative is dy dx equals y squared over 6 minus 2x, then how do I take the second derivative?
Just differentiate.
So d2y over dx squared, I gotta do what to take the derivative?
Take the derivative.
You're getting y squared over 6. It should be times.
Oh, times, sorry. That would definitely change your answer, sorry. Okay, so if that's your derivative, what do you do for the second derivative?
Take the derivative.
And how do you do that? You do the product rule. So I'm going to go first, d second, which is -2 plus second d first, which is nope 2y dy dx. And again, the reason why I didn't have to do dx here was because dx dx is 1, but I have to do dy dx. Arguably one of the more missed parts of this problem, which will definitely hurt you throughout this. This is probably like a 3-point question. That's probably a 6-point question. So you probably got 1 point for doing the derivative, 1 point for remembering the dy dx, and then in the end, you got a point for evaluating. Now, how do I show how to evaluate this? That's right. You don't just plug the numbers in. You have to write and show them what you're doing. I know you guys have been programmed for so many years about just get an answer, get an answer. That's not enough here. You need to show your process. So say, that's the second derivative generically, but it's not even completely done. What do I really need to do to this second derivative? Plug that in for this. Now, you don't probably have to do that as long as you're ending up with the right answer, as long as it's there. But it's better to say, oh, dy dx is y squared 6 minus 2x. It's better to go ahead and insert that y squared 6 minus 2x in there. That is the dy dx. And then say the second derivative at the point 3 comma 1/4, and then at that point they don't really need to see all your work. I mean, they're going to give you credit for actually plugging it in and getting, probably not. They're probably going to give you 2 points for doing this derivative correctly, which means 1 point for that part, 1 point for that part, and then they're going to give you 1 point for an answer. But I'm going to show all the work I have. Y squared would be 1/16 times a -2 plus 6 minus 2 times 3? 0. What a gift. So since that's a 0, all the rest of that is 0, and I end up with -1/8. So they really were pretty kind to you in that regard. But, and that also allowed you to get the answer, right? Even if you forgot the dy dx. So it didn't snowball on you as much. And then back up to this, find the differential equation. So if I'm finding the differential equation, what am I starting with? dy what?
dy dx.
Over y squared equals
6 minus 2x dx.
6 minus 2x dx. So you're dividing by the y squared, multiplying by the dx. And at this point, that's a point right there. So you can integrate. Now you don't natural log this, do you? Anytime it's not a single variable, you have to treat it like a negative exponent. So I'm going to bring the y up, make it a y to the negative 2. But guys, don't do a u substitution here. Remember, if I just have a polynomial, you can take the integral of each part, right? So I see people all the time doing u substitutions right there. Remember, I just can integrate like each part there when it's a polynomial. So I get y to the negative 1 over a negative 1. I get 6x. I get negative 2x squared over 2, which is negative x squared, and I get a c. Now what would you do if you're cleaning this up now? Would you try to solve for c right now? Would you do a little bit more? It's your call. So if you go ahead and solve for c now, you are plugging in the 0.314, and you're getting that c value that goes with this equation. A lot of people end up multiplying through by a negative because they just don't like this negative. And if I do that, your c value changes, doesn't it? Because it absorbs that negative, but if I plug my value in here, that's fine too. You're going to get just a different c value. But make sure you plug your c into that. Like George said, I want to solve it here. If that's the case, that's great, but make sure you plug it back in there. So your c values can vary, but I doubt it would be a good idea at this point to take this y to the negative 1, which is really what? 1 over y. If you flip both sides, where's your c now? Buried in the denominator. So I'm going to solve. I'd probably go ahead and multiply 2 by a negative, but I'm going to solve where my c is very exposed and easy to solve for. So I'm showing my math here. I'm plugging in the 0.314. So what happens when I plug a 1/4 in there and then flip it? So I get 4 equals negative 6 times 3 plus 3 squared plus c. So that's a, what, 13 for my c value? If you solved it the way I did, but I can't plug it in. I have to plug it in there, not here. Because if I solved it from this point, I would have had a negative 13. So here we go. 1 over y equals negative 6x plus x squared plus 13. And what would be the best way to write that? You have to solve for y.
Just flip everything.
Flip everything. Don't confuse flip everything with flip each term. That's not true. When you have a fraction equal to a fraction, you can flip both sides. So I can make this y equals the whole thing, negative 6x plus x squared plus 13. You can make that in order if you want. Probably would look a little bit better. But that is your function f of x, or y equals f of x. All right? Okay, now let's jump to, I'm skipping this mainly because we haven't learned that, but whatever.
We can do it.
Now this is your slope field take-home quiz.
After that, there's like notes.
And we are going to take this. We have got 33 minutes. We're going to do this and make sure we're going to be in good shape. Yeah. We're going to do this as much as you can get done, and then I'm going to run through answers with about 10 minutes to go. Okay? So it's actually not a take-home quiz. got one? Oh, you got it?